Welcome, everyone. This is Generative AI for Social Good. So what is generative AI? Deep learning frameworks can produce new data based on input prompts and large training data sets. We can design these architectures to be able to understand what somebody wants, compare it to data that exists through our deep learning framework, and generate a new response based on this matching process. We have a lot of different frameworks that can exist depending on if we're working with text, with images, even with networks, and they may have some of these steps involved. The encoder-decoder structure, training, sample, matching, or contrastive learning steps, random noise and blending components to the algorithm, and comparison steps to ensure realism. Not all generative AI deep learning networks have all of these, but a lot of these pieces can be assembled as needed when you're creating a new type of generative AI for your uses. A few examples are ChatGPT, the Dolly and Stable Diffusion image algorithms. Hugging Face is a great place to go for any type of text model. A lot of open source models live there that you can play with. And then there's also the option of creating generative adversarial networks that are customized for whatever data types or problems you're working on. Let's go through a little bit of how these algorithms work. So text generators use massive training data sets that are typically scraped from online sources or databases. A lot of times they don't have quality control, or they have some quality control, and most of them are scraped from English sites. So we don't always have coverage in a lot of languages with these models. And they're deep learning frameworks, typically with billions of parameters to train. Some of them are smaller and in the realm of millions, but most commonly they're in the billions. And one of the cool things that we can do with generative AI and some of these text models is fine tune them. So we can feed in specific data that's relevant to the task at hand, such as creating a medical text generator that can answer questions about medical or biological or even legal types of tasks. And you can train these models with these examples using a mathematical framework called LoRa. Image generators come in a couple different varieties. There are encoder-decoder steps in some of the more common algorithms that will pull up related images, blend these images together, and backfill any holes with random noise. There are also image generators that use comparison steps while they're training. So you'll have two competing image generators, one that's a few steps ahead of the other. And these will benchmark against a real data set to ensure realism of the generators. And some of these rely heavily on topology, which we'll see in one of the examples. So a couple of case studies of how these are being used for social good. The first case is medical image generation. Medical imaging often has a lot of data issues. There may be small sample sizes for rare diseases. There might be sample imbalances. So we can think of looking at Huntington's images versus Alzheimer's images. We're going to have a lot more sample from the Alzheimer's patients than the Huntington's patients. And these cause issues when we're training deep learning frameworks or other algorithms to understand differences in images. So we need something that has fidelity to biological structure. We need to have ventricles that look like ventricles. We need blood vessels that branch in the right type of way. And we need variety in image generation. We can't just rotate or flip images. TopoGAN is one of the solutions that involves creating a generative adversarial network on a sample of images using topology. So you can see these different patients and the distances apart. Basically, what this algorithm is doing is looking at distance thresholds and the features that are introduced, such as connected components, as you can see in the middle example. The top two are connected. And then we also have these features like triangles where there's a hole. We can think back to the ventricle example and the blood vessel example for this middle piece. The advantages of using topology within this type of algorithm is that it preserves structures like branching and loops, which make the images closer to what a biological medical imaging example is going to look like with a real patient. And we can generate a large number of images that look biologically real. And that's advantageous for boosting our samples if we have the sample imbalance or we haven't been able to collect enough data due to either small patient populations or limited resources to collect the images. The next case is related to human resource training. MindBloom is a company that addresses these training needs by providing synthetic people with whom to discuss many different types of conversations, including custom ones that a user can create. Some of these include cultural mismatches or policy changes, misgendering, sexual harassment, any of these key HR topics that are usually covered in a static training module can be covered through a conversation and voice generation algorithm. And I'm going to share the demo now. I have this here. The sound isn't going to work on this platform, but I'll speak over this. So here's the site where we can fill out all of this information and select a pre-generated scenario. We have quite a few pre-generated scenarios. We're going to choose the pre-generated scenario. It takes a while to generate, but we'll have a scenario generated that's new. So we'll wait for this to generate, but it'll give a backstory and the initial part of the conversation. A lot of times generating these larger text from these larger models can take a bit. So here we have the meeting brief. So here's our meeting brief and the start of the conversation. Unfortunately, with not having the audio for this, we're going to have to look at just the text rather than hearing the voices that are available. We can press the button to start the call. And since we don't really have the audio, I'll let you just read the responses that come up. So when we end the call, we get a report generation step. So there's a proprietary algorithm and OpenAI's version. So we'll switch back to the PowerPoint now, and I'll show a demo of the report that we auto-generate that scores conversations on skills such as empathy, clarity, and active listening that are usual targets for HR training and communication. And as we can see in the report, we can track these skills over the course of the conversation and get overall feedback of how scores can be improved and how somebody can handle this situation better than they did in the conversation. Another key feature with generative AI is being able to generate proteins. Designing and testing new drugs takes a lot of time and money. This isn't good when we have new pandemics that have urgent needs for treatment, like we saw with COVID, and having a process that involves lots of in-lab testing increases the cost for consumers. So there are many types of proteins and molecules in the venom of different animals that have a lot of biological functions that may be useful in the generation of new types of medications. These include metalloproteinases, three-finger toxins, phospholipidase A2, disintegrants, and many more. The mix of these venoms varies by geography and species, and slight modifications of toxins can be really good drug designs if they're targeted appropriately. However, doing these modifications in a lab takes a lot of time and resources. Using graph generators, we can use generative AI to be able to generate new types of proteins and molecules via our computer rather than in our lab. Basically, we can translate proteins and molecules to graph form by looking at the connections between different amino acids or different atoms. And we can define properties of interest or a binding score from our sample of known proteins and molecules. From there, we can train a generative model to work on generating similar graphs with our targets of interest. This provides biologically plausible molecules that can then be ranked in terms of, say, solubility or a binding score to our protein of interest, and then generated in the lab with a much smaller sample of key new targets that are coming out of our generative model. And these have a lot of different advantages. In studies that have been done so far in pharmacology, we get better target properties out of our generated molecules. We have a lot of variety in the structure, and we have a lot less time and cost to generate these with generative AI than we do having chemists come up with potential targets and then generate all of those molecules and then test them. This decreases time to market and decreases costs to consumers. Public health campaigns are another critical infrastructure that can be helped with generative AI. There have been a lot of recent infectious diseases that can be spread from person to person. We've had Ebola outbreaks, we had the COVID-19 pandemic, we've had HIV, and a lot of different strains emerging in HIV. And there are a lot of limitations with traditional generation of videos and posters and other public health messaging campaigns to address behaviors that are contributing to spread. It takes time to create a script. It takes time to photograph the images or shoot the video, time to translate the entire script for each local population, and there are lives lost in these delays. If we couple a few generative AI features together, we can generate culturally relevant images, generate text, and translate that text to local languages. So here we can see a wearing mask campaign that's generated in Swahili. There are a lot of ethical considerations with generative AI, and we'll go through a few of these now. With image generators, we have the potential for deep fakes. It's been an issue in a lot of legal cases with custody hearings, divorce proceedings, and there's a huge potential to deepfake celebrities or politicians to influence public opinion, which feeds into the fake news issue. Being able to generate a lot of fake news stories and put them out on social media has been an ongoing issue, and being able to tag something as AI generated is one of the tasks being undertaken now to limit the impact of bad users using generative AI for some end goal. In addition to bad actors, we also have some properties within the algorithms themselves that can produce inaccurate results or other undesirable generations of material. Biased data results in biased text generation or biased image generation, and the random nature of these algorithms can allow them to hallucinate or break out of the regulations around them. One instance of this is GPT generating fake citations. So if you ask it to write a report and have citations in there, the citations might not actually exist, but it's very good at generating the structure that a citation would actually involve. And then prompt engineering can also create problems. You can break out of some of the regulations on generative AI platforms by manipulating the algorithm enough to break through some of the safeguards that people put on these algorithms when they release them. Here are a few open source resources. I'll make this available on SlideShare and on my LinkedIn, but these are all open source options for playing around with generative AI for your projects. And there's a lot of collaborations, and I want to thank everybody that I've worked with on these projects for their input and teamwork. I think we can go to questions now. I believe they're in the chat. So there's a question. MindBloom can be used in helping employees have better conversations with each other. Yes, that's correct. Employees having conversations with each other, or managers having conversations with employees. Pretty much any type of workplace communication can be programmed in to the platform to aid in having some of these difficult conversations or some of these trickier conversations to have within a team. On here?
Hi, Colleen. I see two more questions. Are they showing up for you?
No, they're not showing up for me. I only see that one question.
Are you in the question drop down? Just I wanted to confirm.
Yes.
Okay.
Yeah.
Let me send these to you in chat. Is that okay? It would be just a few drop downs. You'll see questions, polls, handouts, and then there'll be chat. And I can
Okay.
send them there. Let me know if that came through okay.
Yes. So one of the questions is, how do I proceed with applying deep learning algorithms when we have limited number of low quality medical image samples? So generative AI is one way of doing that. We can use it for data augmentation. You can take the medical images that you have, apply filters to clean up the quality a little bit. OpenCV is a great Python package for doing that and making them a little bit crisper. And then you can use one of these algorithms like TopoGAN to generate similar images with generative AI before you start training your deep learning algorithm. Data augmentation is one of the big advantages of image and text generation. Oftentimes we do have low quality or low sample size issues within medical imaging or within medical text data. So there's another one on here that says all of the images are black and white in color. Is there any documentation available related to this issue? I'm not sure what that's referring to. If my PowerPoint came up in black and white, were you able to see color on my presentation?
I was. So I'm not quite sure either. If the questioner could follow up and explain a little bit more, that would be great.
Okay, and then it looks like there's one more. Can you add custom scenarios to MindBloom? Yes, you can add custom scenarios, and you can customize the person that you're talking to. So you can pick age, gender, ethnicity, as well as the type of conversation you want to have. We have some pre-generated ones, but we'll also have a feature where you can create the scenario itself. So it's highly customizable.
We've had a couple more come through. I'll be adding them to chat, if that's all right.
Okay. It looks like there's another one. What are the discussions about people not trusting the outputs from Gen AI? There's a lot of discussions about being able to train the public on this and being able to actually tag these. It's pretty hard to tag text generation as AI generated. There's bias that flags non-native English speakers, for example. So that's an ongoing problem of being able to distinguish the writing of non-native English speakers and generative AI. There are a few other groups that tend to get flagged at a high rate of being AI when they're actually people. I've put some of my own writing through this and it's only about 70% correct. So there need to be more discussions and more tools developed to really be able to wrangle this problem. I see another question. What is the MindBloom link again? I only see ketamine therapy in Google search. So we have a website that's coming out. We're going to be launching next week or the week after, and I will have that on my LinkedIn of how to be able to sign up for our free trial. All medical image samples are black and white in color. I'm still a little confused about that, but you can, depending on what medical image data you're working with, it may be in black and white, or it may be something in color, or it may be in a 3D format or a 2D format, and it all really depends on how you're collecting the medical images. The algorithms can generate this in black and white or in color. It just depends on what images you're inputting into the algorithm that you're building. And if you have questions later on, please feel free to reach out to me on LinkedIn and I can answer your questions there. I tend to be pretty available at some point each day to answer questions on LinkedIn.